and today I will be solving the rectangle area second problem from lead code. In this video I will walk you through my approach and the solution I came up with step by step so you can easily understand the logic behind it. Let's dive in. So here's a problem statement. We are given a 2D array of axis aligned rectangles. Each rectangle I Here's a complete statement that denotes the ith rectangle where x, y, and y1 are the coordinates of bottom left corner. So you can understand this more from this example. Here are the rectangles. So we have to basically calculate the total area covered by all rectangles in this plane. So we have to calculate the area that is covered by all rectangles in the plane. Any area covered by two or more rectangles should only be counted once. That's the condition. Return the total area. So here's the complete scenario. So the problem we are dealing with is called rectangle area second. So to solve this problem, we are come up with approach now. To solve this problem, we need to carefully track the total area and avoid double counting the overlapping areas. I have already told you. A brute force solution could be involved checking each possible pair of rectangles, but this would be inefficient. So we are not using brute force approach. Instead, we can use an efficient approach based on line sweeping and interval management. So we are going with line sweeping and interval management. So talking about my idea, the idea here is to first decompose the problem into vertical line segments. So our first thing will to decompose the problem into vertical line segment and track the total area as we sweep from the left to right. Okay, so we will use a data structure to keep track of the active intervals along the y-axis at any given time. So we will use combination of segment tree and a map. We are going to solve this problem into Java language, and while the map will help us manage the start and end point of each rectangle, so that there's a use of map that will help us to manage the start and end point of each rectangle. So starting with my code, so here's a command: store the vertical line segments. Okay, so using list, as I have mentioned, int get and events as new array list, and here's we close the bracket here, sorry. So we can close this bracket here, and moving for next step. The next step is like first step to store the vertical line segment. So by using list, we can you can clearly see here's a list and we have the events with new object array list. The second point is you can do for each rectangle add two events. Okay, add two events, one for the left side, one for the left side and one for the right side. So that's great. We now come up with code. So here's executing my code, that is for int come up with rectangle. Okay, great. And completing that line. So again rectangle. There is some mistake, I think. Yes, now it's right. So rectangles, okay, using this bracket. Events for left side dot add new and come up with idea. So okay, great. Rectangle again is with a value of index 0, and again we are going to the same, we can copy this index through again and again. We'll save on time, but we'll fill here the correct index 1 and 3. Here's a 1 and 3. This is for left side. I think this makes sense. And now we'll put 1 there and close the bracket, and here we can write it for our reference, that is for left side rectangle. Okay, so the same code will be again for right side area now. So we can copy paste it again and reuse it here to make sense. Just we have to one thing, that is we can use here too, and here's a 1 because that will be -1. This makes sense, and just come up with that, and again that is for right side. So that's our basically. Now we are going to sort. So we are now going to sort event by x coordinate, sort events by x coordinate, and then by type, left before right. Okay, now go for code using collections from Java. Dot sort events and a comma b, that's for coordinate we are using here, and a, the index will be 0, again that's b, it will be 0, a again that will be 3, index 3, that's a, and again 0, minus b. Okay, so the next concept is to track active y intervals. To track active y intervals, we can go with code or using tree map. Integer integer, then active, else new tree map. And now we can declaring the variables long last x event dot get. This is the index we are getting 0, and again 0 closed. And the long area we need, actually we need area of the rectangles, so we are declaring that for long area. So here's we have processed half of a problem. So the next part will be starting with the comments. Process each event in sorted order. So we have to process each event in sorted order using for loop. Event events inside the loop integer x is equal to event, and there will be 0 index y1 event one, and again we can use it event 2. So we are just sorting that event in this process. Type will be event 3. Great. We are done in sorting the events in each process. Now we have to calculate the area contribution from the previous x coordinate to the current one. To the current one. So here's a code of starting with area, assigning assignment operator, and there is x minus last x that we have already declared above, multiplying get covered length and that is the active. So we are now again done with the calculating area of contribution from previous x coordinate to the current one. This is the line of code that is help us to calculating that area, particular area. Now we have to update the active y intervals based on the event. So we are using comment update the active y intervals based on the event. So using if else loop we can do that one. If type is equal to 1, so active dot put y1 active dot get, and here you can use can use default y1 plus 1. Doing same with again we can put y2 coordinate, so we can use this in our code. We have to just replace with y2 and it will be y2 also there, and this will be minus here. So this is our updated code. So now we have else statement, else we can, I think we can reuse this. Yeah, we can reuse this. So active put y1 active get. Here is a, we can't use get or default function here. Again we are just dot with active dot get, and just y1, it will be minus 1. So this is right here. If active dot get y1 is equal to 0, then active dot remove y1. Again going for the next line, we use put function to put that y2 active dot get y2. That will be the correct thing. Here's a active dot get y2 will be added with 1, and that will be the same. Now we have to update the next step is update the last processed x coordinate, that is last x will be assigned to x, and get closed, and here will be return function. used to return int area closed in bracket and area using operator. So now we'll use the number 007. This is the complete part of the code. So now again helper function, using helper function. Why we use this helper function here? We are using helper function to calculate the total covered length in y direction. To calculate, sorry, total covered length in y dimension. So the code will be started with private long get covered length using tree map function, again integer active, and now we are declaring the variables long length will be assigned to 0, int prev y, that is the previous y dimension length, that will be -1, that we are already declaring. It is here's a count variable that will use to count that particular area and the number of coordinate we are using here. Now again using for map entry integer I think that's integer close entry active entry set, and brackets will be again brackets again. Now int that for current y, and that was for this was for previous y, and that integer is for current y. Okay, so let's use this for current y, and it will be entry here's entry dot get key method to get that key, and using if condition, if count is greater than 0. Here the special condition, if count is greater than 0, so the length will be, so the length will be equal to current y minus previous y. Here's a complete concept that we are using. So now we can say we are declaring previous y to the current y, so that our current y value will be assigned to previous y. Okay, that's great. We have assigned it also. So now uh, inside this function we will return our length. So length will be returned. So let's look back on the complete code what we are doing here. Here's a complete code over using the in Java the store vertical line segment. First we have stored the line segment, that is list integer event in array list. Again is for each rectangle add two event, one for the left side, other for the right side. So we have two events, that is one for the left side and other for the right side. So this is a complete code we have written in the rectangle area. Second question on lead code 850. We are not going to run this compiler. Okay, that is accepted. So case 1 and case 2 both cases are accepted, and the output will be 49 as per expected. So we can now submit this problem. Before submitting, we have some concepts that we have used. We want to recall it. The key concept was just sorting. So we sort the event by x coordinate to ensure that we process the rectangles in the correct order. So here's a first statement that we have to sort it in the correct order in rectangles. Second thing, we have used tree map in our code. uh, tree map is used to ensure to maintain active y intervals efficiently and calculate the covered length dynamically. Okay, so tree map is used to cover basically to calculate the covered length dynamically. We use the tree map also. And the third one is line sweep algorithm. Line sweep algorithm is the key concept, and this approach is for moving from left to right across the x-axis and updating the active intervals. Is a classic technique in computational geometry for solving problems involving interval area and calculations. And the last one, modulo arithmetic. Since the problem asked for the results modulo, this was the modulo 10 to the power 9 plus 7. So we ensure the area is calculated under this constant. That's the basically the modulo arithmetic. So this is the whole concept behind this problem. This was on a hard problem on rectangle area second on lead code. So we have solved and both test cases are run. So the complete code is this. You can look upon the code again. uh, okay, so this problem has been accepted, and you can see all the test cases has passed successfully. 78 test cases that were passed, and this was the complete solution we have discussed with you. Thank you. And here's if I'm talking about the time complexity about the algorithm. So sorting the event takes big of n log n, where n is the number of rectangles. So this was the time complexity for sorting the events, and for each event we update the tree map, which takes big O of log m, where m is the number of unique y coordinates. So these are the two complexity that were alongside our problem. So here's a complete solution. We can you can refer this on the lead code. Thank you.